Ever heard of space diamonds? Theoretical whole diamond planets? How are they different from Earth diamonds? New research verifies celestial diamonds exist. All that and more. I'm Michael Patterson, and this is Science Now, my new channel where we delve into topics on the latest science and space news. We have all seen diamonds, either on the media or in real life. We know diamonds are created underground by extreme forces and pressure inside our planet. This crystal lattice of carbon has great industrial uses, along with being aesthetically pleasing. The inflated cloth makes it prohibitively expensive, but what if I told you researchers have developed a real, extremely rare diamond inside an asteroid? This small fragment won't make it onto anyone's finger, but the science behind this discovery is fascinating. Earth diamonds are the hardest naturally made substance, right? Well, this space diamond is even harder. Researchers published in the Proceedings of the National Academy of Science, the international team led by Monash University in Australia, have physically verified the existence of a rare hexagonal structure of diamond called Lonestellite inside a meteorite that came from a dwarf planet that formed 4.5 billion years ago. The name Lonestellite comes from a renowned pioneering crystallographer and prison reformer, Dame Kathleen Lonesdale. She proved in 1929 that the benzene ring, the backbone to a lot of chemicals, was flat in nature by using X-ray diffraction methods, and developed several other X-ray methods for studying crystal structures. But back to the study, this proves categorically that Lonestellite exists in nature, said Professor Dougal McLaughlin from RMIT University, who is the director of the RMIT Microscopy and Microanalysis Facility and co-author of this study. We have already discovered the largest Lonestellite crystal known to date that are up to a micron in size, much smaller than a human hair. This research opens the door for the development of new manufacturing techniques to create even harder materials. There is strong evidence that there's newly discovered formation process for the Lonestellite in regular diamond, which is like a supercritical chemical vapor deposition process that has taken place in the space rocks, probably in a dwarf planet shortly after a catastrophic collision, said McLaughlin. Chemical vapor deposition is one of the ways that people make diamonds in the lab, essentially by growing them in a specialized chamber, said McLaughlin. Saturn is often the planet that people think about that grows diamonds to rain down onto its surface. In much the same way, the methane in the atmosphere combines with the pressure from the dense atmosphere, and the violent storms cause the carbon vapor to collect like snowflakes. Scientists have long theorized diamond planets, and with two local planets that can rain diamonds, it's not a far stretch to believe a whole planet could be diamond. NASA has even taken a closer look at 55 Centauri, an exoplanet dubbed the Diamond Planet due to its carbon-rich composition. Imagine the value of the planet. Well, that's it for this episode of Science Now. Please leave a like, share with someone who loves to learn about space and science, and if you're subscribed and have the bell icon on, you're awesome, and I'll see you in the next one. Thank you, and goodbye.